So again, welcome everyone. Thank you for joining today's webinar. Today we have joining us Dr. Ahmed Hasham and Dr. Eman Boshnak. I will turn it over to Ahmed in a minute to introduce, but first off, I wanted to welcome you to our webinar, Biogas as an Ideal Solution for Environmental Pollution. This is the third in our Earth Week webinar series. We will record the webinars and make them available for viewing for other time zones and to share with other Kemen employees. So I'm glad you joined here today. So Ahmed, I will turn it over to you. You'll have to unmute and introduce our speaker for today.
Hello everyone, it's my pleasure to be with you in this webinar. I will introduce Dr. Eman Boshnak as a speaker for this session. Dr. Eman already had her master's degree in environmental chemistry and her PhD degree in organic chemistry. She did a lot of researches about biogas and sustainability. So let us give her the chance to present her presentation about biogas and its consideration as ideal solution for the environmental problems. Dr. Eman, you are welcome. Please start your presentation. I think till now you are still muted.
I'm so glad to be with you today and thank you for your attendance. It's my pleasure to be with you. Now we will begin. We will speak about biogas as an ideal solution for environmental pollution. Major kinds of pollution can be classified into air pollution, water pollution, and soil pollution, as you know. Biogas is produced by anaerobic fermentation of organic wastes. So when we talk about organic waste, we know that accumulation of organic waste make a lot of problems, cause harmful effect on air and on water and on soil. Okay, what is biogas? Biogas considered a flammable gas which consists of many mixture of gases. This biogas is produced in specific conditions in anaerobic condition. That means that this biogas is produced by fermentation of organic waste in absence of oxygen, and that need some methanogenic bacteria. As here, the biogas unit, here the inlet chamber, then the main chamber and outlet chamber. Here we put the organic waste, and the organic waste is fermented here in the main chamber. Biogas is evolved from here and exit from this gas valve. The remained solid waste can be exit from this outlet chamber. This remains solid waste called this digestate, which can be used as a high quality fertilizer, which contain high nitrogen, high phosphorus. These elements are very important for agriculture. So biogas not only a clean source of energy and a renewable source of energy, but it's also a renewable source of fertilizer. So biogas composition. Biogas not only one type of gas. It's many mixture. It's considered a mixture of gases. Methane is from 50 to 75%. Carbon dioxide from 30 to 45%. Nitrogen from 1 to 2%. Hydrogen from 0 to 1%. Carbon monoxide and other traces from 0 to 1%. The efficient gas in carbon in biogas, the efficient gas which make the biogas has its properties and make biogas flammable is methane. So as we increase the amount of methane, we improve the quality of biogas. Biogas properties, as we discussed, that biogas mainly consists of methane, so have similar properties as natural gas. Density liquid, when we liquefy the biogas, the density will be 1.2 kilogram per cubic meter. Calorific value of biogas is from 4 to 7.5. Ignition concentration gas content is from 6 to 12. Biogas technology has many advantages as we speak in detail. Biogas considered renewable energy. As you know, world economy dependent today mainly on crude oil and natural gas, and this type of fossils is non-renewable, and also it's very harmful to our environment. But now we talk about renewable. So biogas from wastes, and waste doesn't end. So biogas is a major advantage of biogas. So second advantage, reduce the greenhouse gas emissions and mitigation of global warming. Greenhouse potential of methane is more than greenhouse potential of carbon dioxide. We always care about carbon dioxide, but we ignore methane. Methane is higher than that methane potential of greenhouse effect potential is higher than carbon dioxide by 2-3-fold, and by nitrous oxide by 296-fold. So methane is more dangerous than carbon dioxide and nitrous oxide. We can use this methane for ignition and for here we will speak about waste reduction. By using biogas, we reduce the waste, and this waste will affect not only emission of biogas of methane, but also these emissions affect our air and affect the soil by parasites and microorganisms, and affect water and underground water with okay, here we speak about job creation. Biogas technology needs high work power for production and collection and transportation of anaerobic digestion feedstock, manufacture of technical equipment, construction, operation, and maintenance of biogas plants. The flexible and efficient end use of biogas. As you know, that biogas contain mainly on methane. Methane we can use methane for cooking, and also we can use methane for combined heat and power generation, for generation of electricity. So it's flexible. Additional income for farmer involved. Farmer can save the money which will buy LPG cylinder or natural gas by using this biogas unit, and also can save his money by using this organic fertilizer. Digestate is an excellent fertilizer, as we discussed before. Digestate, this digestate, which is a solid waste which remain from a digestion process, anaerobic digestion process, contain rich in nitrogen, phosphorus, and potassium, which is very important for plants to grow with high quality. Flexibility to use different feedstock. We can, in generation of biogas, we can use different feedstock. This flexibility make a different application and different projects and different. We can use animal manure, slurries, crop residues, organic wastes from dairy production, food industries, and agro industries, wastewater, sludge, organic fraction of municipal solid wastes, organic wastes from households. Reduced odors and flies. Accumulation of wastes make unpleasant odors and make a lot of flies in the place of accumulated organic waste. So biogas in United Nations has 17 sustainable development goals. Biogas can achieve 10 of 17 of these sustainable development goals. So it's very important. Here we will discuss with detail what the anaerobic digestion process. What is the steps of anaerobic digestion process? Mainly, this is the main equation: organic matter plus water will produce methane, carbon dioxide, new biomass, which we consider a fertilizer, ammonia, hydrogen, sulfide, and heat. This is the main equation. Here we will discuss the 4 steps. We have 4 steps for anaerobic digestion process. First, Any organic matter contain carbohydrate, protein, lipids. It's in its content of organic matter. Any type of organic waste, not a specific type. So carbohydrate, the first stage is hydrolysis. Here carbohydrate will change and convert it to monosaccharide. As we discussed, hydrolysis is the first stage of anaerobic digestion process, which converts complex organic material to soluble organic compound. Carbohydrate change to monosaccharide, protein change to amino acid, and lipids change to fatty acid. So the second step of anaerobic digestion process is acetogenesis. Acetogenesis here, monosaccharide and amino acid and fatty acid will change into volatile fatty acid as propionate and butyrate and valerate. The third step is acetogenesis. Here, formation of acetate from volatile fatty acid. Then the stage, fourth stage is methanogenesis. This step is here methanogenic bacteria work and formation of methane and carbon dioxide. Which is biogas. That is the equation with details. For stages with equation with details. Now we will talk about main types of biogas plants. We have two types of biogas plants. Floating gas holder type biogas plant. We accurately have a lot of types, but we have two main types of biogas plant. But accurately we have many types. We have floating gas holder type and fixed dome biogas plant. It's a comparison between floating type and fixed dome. Floating type have a high capital investment, and fixed dome have a less capital investment. Cost of maintenance of a floating type is high, and cost of maintenance of fixed dome is minimum. Lifespan of the plant, floating type plant, is expected to be 30 years, and that of gas holder is 5 to 8 years. But the lifespan of the plant, fixed dome plant, is comparatively more. Steel gas holder is essential, which requires steel gas holder is not maintenance, require maintenance, such as painting and repairing and replacement of damaged part due to corrosion. But in fixed dome, steel gas holder is not required because it depends on the dome, not on a floating type of gas holder. Floating type, locally available material can be used for construction of digester. Fabricated gas holder is to be transported from nearby towns. But in Foxodome, the entire plant can be constructed with locally available material because it depends on some bricks and there is no manufactured parts. The space above the movable drum can be used for other purpose, but fixed dome always under the ground, so the space above the plant can be used. Effect of temperature. Temperature affect have a major effect on production of biogas. Floating type always on the ground, not under the ground. So temperature can temperature of winter, cold temperature affect on production of biogas, but in fixed dome there is no effect of temperature. The gas released at a pressure of 8 to 12 centimeter of water column. In fixed dome, the gas is released at pressure of 90 centimeter of water column. Here in Egypt, I built a biogas unit in a fixed dome design. As you see in the picture, all the biogas unit here under the ground here, and this is the gas valve, and this is the hose which go to the to use the biogas for heating. So this fixed dome this type is called fixed dome. Its volume is 7 cubic meter of biogas. In this fixed dome, which we built here in Egypt, in European country, here in Egypt, European village, here in Egypt, in Cairo, Alexandria Road. We measure a lot of parameters to improve the quality of biogas and to increase the methane content. There is a lot of parameters. First parameter, the feedstock. When we bought some agriculture waste, we obtain biogas with amount of methane different than we put animal waste, different than we put chicken waste, different than when we put different types of waste, we get different qualities of biogas. In addition, when we enter laboratory form, we smell a lot of ammonia. So here ammonia make as inhibitor for anaerobic digestion process. So it's our work to get rid of this ammonia. Pre-treatment. We have a lot of types of pre-treatment. We use mechanical type of pre-treatment, but there is the biological pre-treatment, thermal methods. A lot of enzyme pre-treatment by enzymes, there is a lot of types of pretreatment. Carbon-nitrogen ratio. We measure carbon-nitrogen ratio of the feedstock. Carbon-nitrogen ratio is very important because when carbon is very high, inhibit the anaerobic digestion process will inhibit. And when the nitrogen is very high, the process will inhibit. So the ideal ratio is between 15 to 30. When we put type of feedstock with the high, when we measure that high carbon-nitrogen ratio, we must make co-digestion to reach this 15 to 30 carbon-nitrogen ratio. Temperature, as we discussed, the temperature has a major effect on production of biogas. We have 3 ranges of temperature: psychotrophilic, mesophilic, and thermophilic. Psychotrophilic is 25 degrees centigrade, and mesophilic from 25 to 45, and thermophilic from 35 to 70. We found that the best condition for production of biogas is in mesophilic. Here in Middle East, this temperature is very available. pH and alkalinity. pH and alkalinity, biogas is affected a lot by the pH of feedstock. So we must measure the pH. Ideal pH is between 6.2 to 8. This is the ideal range of production of biogas. Retention time, we must know every feedstock have different retention time in the digester. Volatile fatty acid. Here, volatile fatty acid, a lot of volatile fatty acid will affect the production, the pH of the digester. So, volatile fatty acid can inhibit the digestion. We must adjust the amount of volatile fatty acid. Ammonia, as we discussed, as we say before, that ammonia make an inhibitor. Co-digestion to adjust the amount of carbon-nitrogen ratio by mixing between different feedstock to reach an ideal carbon-nitrogen ratio. Thank you for your attendance, and I wish to meet you again. Thank you.
Thank you, Dr. Eman, for your presentation. I think Dr. Heather will continue.
Yes, thank you very much. That was very interesting. You're very knowledgeable on your subject. I do have a couple questions that came in. If you would like to take some time to address those, I'll put them in the chat and share them.
Where is the question? I don't see it.
I will put it in there. Let's see.
Where
So
is
the first question is, what are the challenges to burning or to using biogas at larger scales?
Challenge, there is no challenge. Biogas unit for production of heat. If we use a fixed dome digester, we don't need a lot of area of the land. so there is no challenge, but we will build the same biogas unit with a lot of bricks, and there is much. But when we speak about generation of electricity, that is a new technology, and there is the filtration of hydrogen sulfide, and there is a lot of chemical treatment for biogas technology for production of electricity.
Great, thank you. Yeah, the next question is for the dome that you built, what was the gas that was produced used for?
Okay, we use this biogas for heating in the farm to save production, buying LPG, because the farm in a far away, we use it for heat. But we use also, when we make a poultry farm, a small poultry farm, for warming the farm for chicken.
Dr. Heather, you are muted.
So the next question there is there potential for biogas to reduce conflict associated with fossil fuel supply through larger adoption of biogas use?
Yes, biogas have a potential to reduce, if we use it a lot, I think it will save a lot of process.
Are there any other questions from attendees? Well, I want to thank you so much, Dr. Boshnak, for joining us today. And thank you, Ahmed, as well, for joining us and introducing our speaker. And I would like to share that there are still time to sign up for tomorrow and Friday's additional webinar. On Friday's webinar, we will discuss Kemen's actions toward taking climate action and where we're at with that process. So thank you all for joining today, and I appreciate our speakers.
Thank you, Dr. Christine and Dr. Ahmed Jem and attendants. Thank you.
It's our pleasure to meet you today. Thank you.